Hello, COM1407 Computer Programming Lecture Series. Today we have to cover the lecture number 8, which is working with functions. The objective of this lesson is, at the end of this lecture, you should be able to describe the C functions, practice the declaration, parameter passing, prototyping and calling functions, justify parameter passing methods, practice creating user-defined C header files, justify the variable types and scope roles, and describe the concept of recursion, apply taught concept for the writing programs. Let's move to the next part, which is the introduction section. A function groups a number of program statements into a unit and gives it a name. Function is simply it groups a number of program statements and we can give a name for that part. This unit can then be invoked from other part of the program. We can make use of existing functions available in these various C libraries. The standard library provides a rich collection of functions. What does that mean? At the very first program, when you are going to write a C program, what do you do? First, you have to include some library functions. In library files, you know, the basic library file that you are using is standard input output stdioh. Inside this library file, it consists some set of already defined functions. Examples are the printf, scanf. These are the functions which are written inside this stdioh.h library file. Therefore, when we are including that library file, after including the library file, we can use these functions. That's why we can call the printf functions scanf functions, because these are already written in the library files. In addition to that, we can also write our own functions. Let's learn how to write our own functions. Before going to with the writing program with the functions, let's learn why we are using functions. Actually, when modular in programming, its functions are very useful. Reduction in amount of work and development time. Program and function debugging is very easy. Reduction in size of program due to code reusability. Functions can be accessed repeatedly without any redevelopment. Basic advantage of the using function is the reduction in amount of work. Because as an example, if you wanted to done a certain task, to set of instruction for that task can be modulated into a functions, and each and every case when we want to apply that, we can just call the function. As an example, if we want to add two numbers within a certain program, you have to do same task in several times. What you have to do? Simply you can write a function to add two numbers. Then whenever you want to add some functions, what you have to do? Just call that function. That is the very basic example how functions can help to reduce in amount of work and development time. Here, this is a example for the function definition. Okay. Here, you can see return type should be their function name, and inside these parentheses you can have to what are the parameters we are passing inside to the function, and inside these curly brackets we can write these statements. Statements can be either declaration statements or executable statement. Declaration statement must be started at first within the function body, and return value must be equal to the return type of the function. Here you can see here return type. Meaning of that means return type of a certain function means that the return type of the value that you return at the end of the function for where the calling place. As an example, if we write int as a return type, here we have to return an integer type variable. Okay. Here this is an example for that. Here this is a function void print name. Here return type of this function is void. That means this function no need to return any value. This is the function name, print name is the function name, and it does not take any parameters. Okay, inside this function what it does? It printf this statement. My name is Saman, and this is another function. Here return type of this function is double, and calculate sale is the function name, and it does not take any parameters. Okay, inside this functions what it does? Here it takes a integer type variable quantity, and there's double type two variables are there, unit price and total. Finally it returns what it does, total equal quantities multiplied by the unit price, and finally it returns the total value. What is the return type of the what is the data type of this total variable? That is double. That's why at the very first, when functions declaration, it says this function return a double type variable. Double calculate sale. That means that this function returns a double type value for the calling position, calling place. I will explain that how it works. And there's another method, double calculate sale, and it takes two parameters, quantity and the unit price. Quantity is integer type, double unit price is double, data type of unit price is double. Finally it also return the total, and it is a double, data type of the total is double. That's why it says here it says this function returns a double type variable. Okay, I will take a simple example and make you more familiar about these functions. Okay, wait for a while. Here you can see my screen. Here this is the include directive, and I have written two functions. One is void print name. This is a function. Return type of this function is void, and name of the function is print name, and it does not take any parameters. Printf my name is Saman, and this is another function double. Return type of this function is double, name of the function is calculate sale, and it takes two parameters, quantity and the unit price. Quantity is in data type, and the data type of the data type of the unit price is double, and it does this arithmetic manipulations are there, and it returns a total which is the double data type. Okay. Inside the main function, this is the way of calling a function, print name function. It calls print name function. Here you can see when we are calling a function inside the main method, you are not writing a return type, just print name. Here it calls the print name, this method. When it come to here, what it happen? It printf the my name is Sama. This statement should be printed. Then after that, next line, it says printf total type sale list. Total sale list. Here calculate sale. It calls this calculate sale method. When it comes to this calculate sale function, what it does, it takes two values, quantity equal 10. Here it passes in two parameters, 10 and 10.5. 10 means quantity, 10.5 means unit price. Then it multiplies this quantity by unit price and return the total value. Here this total value is returned into this position. Okay, this total value returned to this place, and finally it has to print the value. Clear? Okay, to make you more clear this thing, I'll take another variable double total equal okay. I commented this line, then I say okay. Here what I did is I create another variable called total and assign the value of this method. What is this method returns a double type value, that is the total value. Let's see, I'll save that one. That is error in my printf method slash in it should be total let's see. Okay, this is the error that I have not insert this one. Okay, here this is the output that I got. My name is Saman and total sale is this value. Here when you come to this, you can see here print. When we call this print name method, it goes inside to this print name function and print does what inside and print the my name is Saman statement. And what it does, it come to here double total. This is a variable, double type variable. This total variable equal to calculates. This is a function, but this function return a value. Where this value return to the place that call in. This function call is done by from here this point, then total equal this return value, that is the total. Then printf total sale is this total value. Okay, same. This is the same thing. We can done like this also. We can just do this one rather than writing these two lines. What it does, printf total sale. Sorry, this is the calling place. Total sale equal to this. The function is called from here. Here you can see. Here the function is called from here. This return the value. Return in value is passed to this point. Here we can see total sale is here, floating point value. Here you can see when we write, compile and write this one. Here my name is Saman, total sale is this. We can change the value. Rather than 10 we can say 20. Let's see the output. Here does not change the output. Let's see. Sorry, I have not changed it here. Okay. Here it has changed the value. Here I think you get the idea behind what is the function is. Here function is a set of written codes. We can name that set of codes and we can call from anywhere. From the inside the main function we can call these functions. I think you have got the idea. Okay. And next thing we have to know what is the function prototype. Here these are the examples for the function prototypes. At the very first of the certain programming, we have to write the prototype of the functions that we are used inside the program. We call that as a function prototype. In previous example, we can write for the print name function, we have to write the return type and function name, and if we are using any parameters, you have to mention only the data type of this function. Here as an example, we can write the prototype of this function is data return type is void print name. There is no any return types. Next prototype is double calculate cell. Here no need to write this name of the parameters, just we wanted to write the data type of these parameters, int and the double. These are the prototype. We are at the very first we are writing the prototypes of these functions. Okay. And also, why we are function prototyping is essential. The main reason is that they exist is so that the compiler can go through the program exactly once, knowing which functions are scoped at any given time. To do this, functions would have to be declared before they are used. Prototypes let you declare a function without implementing its body until later. Here, example. When you take this program, you know these two functions are written at the very first of the program. Instead of that, we can keep them at the end also. We can keep them at the end. Okay. Here, preprocessor know when we are doing this prototyping at the very first of the program, the preprocessor knows that these are the functions that are inside the program. Okay, when it comes to here, this is the position where the print name function is calling. Although print name is not declared or this function is not written at the very first, but this declaration is there, this prototype also there, then preprocessor get to know there is a function called print name inside the program. Then it find the program and call that print name for function. That's why this prototyping is essential. We can put our functions anywhere else in the program, but at the very first we have to declare, we have to mention that these functions are inside the program. We call that as a prototyping. I think you can get the idea of that. And also, this is a one way of writing the prototype. Also, if we write this also correct, it also not wrong. Here, quantity and the unit price, you can write this one also, but no need to do this one. This is enough. Okay, this thing also enough. Calling a function. While creating a C function, you give a definition what the function has to do. To use a function, you will have to call that function to perform the defined task. When a program calls a function, the program control is transferred to the called function. A called function performs a defined task, and when its return statement is executed or when its function ending clause in braces is reached, it returns the program control back to the main program. When a certain call function performs certain defined task, and when it's returned to this statement executed or when it function ending come to the clause in brace reach, it returns to the main function where that function is called. Here in this example, here when it comes to this print name function, it goes to the jump into this printf print name function and it does what it's declared. Then after that, when it comes to this closing braces, again it jump into this point. Again it jump into this point and go to the next line. Okay. To call a function, you simply need to pass the required parameters along with the function name. And if the function returns a value, then you can store the return value. Here in this example, when we are calling this print name, no need to pass some parameters because it does not take any parameters. But this calculate cell function takes two parameters. Therefore, you have to pass these parameters at the when calling time. When you are calling this calculate cell function, you have to pass two parameters. One should be integer type and the other one should be double type. Okay. The C compiler assumes that the function returns a value of type int as the default case. More specifically, when a call is made to a function, the compiler assumes that the function returns a value of type int unless either of the following has occurred. The function has been defined in the program before the function call is encountered. The value returned by the function has been declared before the function call is encountered. Okay. Calling for function. Let's continue this. The C compiler assumes that the function returns a value of type int as default case. We have talked this one, and the function has been defined in the program before the function call is encountered. If these things have been occurred, that's no problem, but if this compiler has not defined, in default case it identifies as a return type as the integer. The value returned by the function has been declared before, that's no problem, the function call is encountered. If not, it take the return value as the integer. Okay. When passing parameters, here this is the prototype of the function double calculate cell, that is the function name, integer and double. Here this is the function definition is there, double calculate cell. Two parameters are passed, quantity and the unit price. Okay. Here I have done this example. Here we can call this calculate cell by passing two constant as the argument. You know what is the constant? Here 10 and 10.5 are constant values. Also we can pass the variables as the parameters. Also we can pass the constants. Here we have passed the constants. Can't we pass constant and variables as argument for a function? Actually, yes, we can. We can pass constant and also variables. This is example. For the passing the constant, this example for the passing constant as arguments here. This is the example for the passing variables as the argument. Int main. Here there are two variables are there, integer type units and double type unit cost. Here total sale equal, calling the calculate sale function, we are passing two parameters. First one should be a integer, second one should be a double. Then we are passing units and the unit cost. Printf total sale should be this total sale. Okay, simple one. This is the demonstration of another program. Here there are two functions are there inside this program. One is the void asterisk chart in char. It taking two parameters. Data type, first one is integer, second one is the character. So it takes, in this program consists only one function, not two. This is the function body. This is the prototype. First line is the prototype. This is the function body. Int number, char style, int x. Here int x for x equals 0 to x less than number, x plus plus, printf this style. And this is the end of this asterisk chart function. Inside the main function, it says m1 and m2. There is two variables integer type, m1 and m2. Printf enter the percentage score of group 1 and group 2. And it takes the m1 and m2. Printf group 1 and it calls the asterisk chart. What are the variables that pass this m1 and this asterisk? m1 is the variable and get the value for m1 is from the user entered value, and it pass this asterisk character. Here what it does, when it come to this number equal whatever, let's see, user has entered number 10, char style equal this asterisk mark. Then for x equals 0 to until x less than number, what is the value of number? That is 10. X plus plus, printf this style. What is the style value? That is asterisk value. What does function do? It prints this asterisk character in 10 times, and at the end of this loop it go to this function, it go to the new line. Okay, and then jump into this calling place. Here it come to here, then printf group 2, then again it calls this m2, which is entered by the user, and it print, if the user entered 20, it print 20 asterisk marks. Okay, let's see this example. Okay, here this is the prototype of the function, and this is the function declaration. Okay, I will save that one. I have saved that one as function2.c. There are some errors are there. Strict chart. Okay, to track these errors, I will comment these lines. Let's see what will happen. Okay, so I will remove this one. I have to track the errors. There are no errors there. Problem is here, no? Chart and okay, I want to print 10 and 20, 10 and 20 values. Then it print the 10 asterisks and the 20 hashes. Okay, here in these functions, asterisk char function takes two parameters. One is integer type parameter to emphasize how many times this should be print, and the character that you wanted to print. You can see when you look at this one, if we don't have this one, if you have not used this function, what we have to do? We have to write this, okay? Control C. If you have not written this function each and every time, instead of this line, I have to write this one. You can see for x equal to 0, x less than this one, I have to print, this and printf slash n. Okay, if you don't have this function, then again what we have to do? When we want to print this one, same code line I have to put here also. Okay, you can see here using function, it is very clear we can reduce the number of code lines. I think that thing is very clear for you all. Okay. these are the advantages of functions. Functions help to avoid duplication of effort and code in programs. During the development of a program, the same or similar activity may be required to be performed more than once. The use of functions in such situations avoids the duplication of effort and code in programs. This reduces the size of the source program as well as the executable program. It also reduces the time required to write, test, debug and maintain such programs, thus reduce the program development and maintenance cost. I think these things are very clear to all. And when we talk about more about this function, allow the divide and conquer strategy to be used for the development of programs. When developing even a moderately sized program, it is very difficult if not possible to write the entire program as a single large main function. Using function, we can module that program. Such programs are very difficult to test, debug and maintain. The task to be performed is normally divided into several independent subtasks, thereby reduce the overall complexity. A separate function is written for each subtask. In fact, we can further divide each subtask into smaller subtasks, further reduce the complexity. Rather than the reducing the number of code lines, we can use these functions to allow the divide and conquer strategy to be used for the development of programs, and further it reduces the complexity also. And also, functions enable us to hide the implementation details of a program. Example, we have used library functions such as square root, log, sine, etc. without ever knowing how they are implemented inside there. We can no need to worry about that because these are already implemented inside the library files. What we have to do just only use them. However, although we need to know the implementation details for user-defined functions, once a function is developed and tested, we can continue to use it without going into its implementation details. If it is right, if it is correct, no errors, we can further use again and again. No need to worry about how it has implemented. Another consequence of hiding implementation detail is improvement in the readability of a program. Proper use of function leads to programs that are easier to read and understand. The function developed for one program can be used if required in another with little or no modification. This further reduce the program development time and cost. Okay, this is the end of the first part of the functions. Up to now, we talk about what is the function, how to write a function declaration, how to write the prototype of a function. These things we have talked, and we have further discuss about the advantages of the functions. What you have to do, you have to write the programs by you own. For you have to try these given examples. After that, you should be more familiar with the functions. Tomorrow you have the practicals on the functions. Before tomorrow, I will upload another part 2 of this lesson, that is the parameter passing method for the next part. Up to now, you have to practice on these things that you have done up to now. Okay, thank you very much.